Hello everyone, in this video I wanted to show you the performance on this machine using Fortnite and some other benchmarks. It's an i7-920. It's the first ever i7 to be mass produced. It's the 2008 model. I made some modification on the back of the motherboard to cover the fact that there's some VRM that are not actually under the heatsink. One thing that is very interesting is that while I was testing this, I actually noticed that by using DirectX 12, I was getting actually some better performance in the real gaming time. Because when using performance mode, I would get maybe 150 FPS on the counter here, but actually the game was a bit stuttery. Like it would stutter every maybe 10 to 20 seconds. It was not unplayable, but yeah, it was breaking sometimes with the fights. I would have a fight and I would lose it because I was having a little small of stutter. While if I use DirectX 12, the stuttering is much less pronounced. It's not a night and day difference, so it's not like it's not game changing, but it's there. So I prefer to play with DirectX 12. Also, the game looks a lot better with DirectX 12. Of course, I'm playing with 100% resolution at full HD, 100% rendering, and epic visual distance, and everything else is set to low, to minimum. Yeah, I will try to show you a little bit of gameplay. In the meanwhile, I will talk about the system. So this machine was bought brand new from Amazon for 400 euros, so it was a huge scam. The person bought it because it was RGB, it had an i7 and it had an NVIDIA graphics. It had an NVIDIA GT 1030, so it was really crappy. But I guess that's marketing, it works. Oh, there's something in there, I guess. So the machine came with two 8GB sticks, so 16 gigs of RAM, but it was only dual channel, while this machine supports triple channel. So I swapped the RAM for 6 2GB sticks. This way I could give him a discount because I was actually getting the 8GB sticks in return. And I put an Rx580, and the 580 is the Chinese version, which means that it actually has 2000 shaders, so it's actually a 570. And I heavily undervolted and underclocked the GPU and power limited it because this machine only has a 400 watt power supply and only has 288 watts on the 12-pin rail, 12 volt rail. So here's the crappy PSU, and I don't want this to blow. and the system is actually CPU limited anyway, so that's why I choose to set the power of the GPU to maximum 100 watts. And I use a Radeon BIOS editor, a Red BIOS editor, to undervolt it, which gave me almost stock performance. I will show you the 3D Mark score now and the power figures. So here it is. Here's 3D Mark. So it's 10,000 points, which is quite on it's a 570 actually. So for a 570, that's quite an average score. And the clock hovers around 800 megahertz because I am limited to 100 watts. Let me show you with hardware info. This is a client PC, so it has his own desktop screensaver. So let me get back to the game while hardware info gets the information. Okay. So here we go. So the power limit is around 100 watts. So the GPU is now using 84 watts and it's running at 987 megahertz for the core and 1069 for the memory. So it's very efficient this way. It's a very efficient GPU. It's still using more than double the power of the original 1030, but the performance is like 4 times. So definitely worth it. And of course, the system is also tuned. I have undervolted the CPU. at minus 160 millivolts. So the cooler is very crappy. It has RGB on it, but it's a very low quality cooler with no heat pipes. But it still keeps under 85 degrees during gameplay and Cinebench and stuff. Of course, the CPU is like very stressed under this any kind of game, because it's a very old first generation cheap CPU. And the main limit of the CPU to me is the lack of AVX instructions, because otherwise I could probably play any game. The actual CPU performance is not that terrible. It's a 4 cores, 8 threads, and the memory performance is very good because it's DDR3 triple channel, and the memory latency is very low. I turned the RAM to command rate 1. It was by default command rate 2, and yeah, it performs very good. As you can see, the gameplay is perfectly fine. And if I was playing with performance renderer, I would get 150 FPS here, but I would get more stutters. And I guess I already said that. So yeah, let me show you the temperatures. Now the CPU is sitting at 67C, command rate 1 for the memory. The clock is a stock 2.9 gigahertz. I don't know if I can see the CPU voltage. Yeah, it is 1.12 for the CPU core. Probably it was standing at 1.3 default voltage, and the CPU is actually standing at 50 degrees. And I wonder if the fans, the fans are spinning. Oh, here it is. They are actually slowing down now. They stopped because I am not focused. So yeah, I guess this machine makes sense now. I only needed to swap the GPU actually. Like the CPU, I can actually upgrade to a 6-core Xeon. I could maybe do that, but again, I think that as long as it still doesn't have AVX2, so I don't think it makes that much of a sense for the time investment to actually swap the CPU for a 6-core, because in the end, it's all about the lack of AVX. Yeah, I can also show you some other results for Geekbench. Geekbench 6 results are awful, and again, that's because the lack of AVX for sure. Here it is, I think. This is the GPU score. Here it is. So the CPU score is this one, which is really, again, very awful. It's still way above average, but yeah, not great. Oh, I'm dying. I'm dying. But yes, I guess I'll show you something else. And here I am running the memory latency checker, which is an Intel benchmark for memory access. And like you see the bandwidth and the latency, and the results being a 16-year-old system from 2008 are actually very good. The bandwidth is 21,000 megabytes per second, and the 77 nanoseconds of latency, it's about the latency is on par with DDR5 memory now. If you don't tune DDR5, you're gonna get maybe even a higher latency. Of course, the bandwidth is 1/4, but I mean, again, 16 years have passed, and it's still very good. And that's all, I guess, for the video. Ciao.